27. Okay, fine. Okay, good morning.
Morning, sir.
Good morning,
Today,
sir. Good morning, sir.
and today we are going to discuss about managing input-output operations in C. As you all know, this topic is already being dealt in the class, but this presentation will be an extension of that, and for the benefits of those students who were not present in the class. Okay, so shall we run through the presentation?
Yes, sir.
Yes, sir.
Yeah. So basically, the content of this presentation is taken from our a reference book, NCC, authored by Balaguru Swami, and it is also taken from another textbook, which is authored by Deitel and Deitel. Okay, so the learning objectives of this particular topic is to understand how to read and write characters, also to understand how to read and write formatted and unformatted input outputs. So you can ask me any questions in between. I would rather feel happy to answer your queries. So to begin with, the input output functions in C is broadly classified into two categories. The first one being the formatted input output functions. Second one being the unformatted input output functions. The formatted input output functions allow programmers to specify the type of data and the way in which it should be read in or written out. On the contrary to formatted input output functions, C also supports unformatted input output, wherein you need not specify the type of data and the way it should be read or written. Now, some examples of formatted input output functions, as you all know, are scanf and printf functions, whereas unformatted functions are getCare, getS, basically stands for getString, printCare, and putS. So to start with, we'll try to understand the unformatted functions, input output functions. To read a character, we can use a function getCare. And this getCare, the general format is given in the first line in the red font, where you have variable name that is equal to getCare. Now it is a predefined function, and the header file is available in stdio.h. It is used to read a single character from the keyboard or the console input. Now this is a small example program where I have used getCare function. Here you can see that I've included stdio.h, and then in the main function I have printf, %c, and getCare. The getCare function will read a character from the user. So you can see in the blue font, if you give G as an input, if you press the key G, the output will be G again. So GetCare reads G, printf displays G. Now similarly, for writing a character, use a function putChar. The parameter that we need to pass is of type character variable. You can see here. This function is used to write a character, of course, unsigned character, to the standard output screen. Okay, now guys, I think somebody is trying to draw something on the screen, so please avoid that. I think I can stop that, right? Okay, good. So this is a example program to illustrate putChar method. It's quite simple, as you see. It's a main function declaring a character variable ch, initializing it with uppercase G. Then I'm calling putChar function, passing ch as a parameter. Obviously, when you run this program, you get G on your screen. So there are certain set of functions, character test functions, that will be very useful for us in programming. The header file that we need to use for these functions is ctype.h. Now the functions are listed in this slide. The first function is alphanumeric. ISALNUM is alphanumeric. We are passing a character as a parameter here. Now this function will certainly return true if C is a alphabet or a number. When I say a number, whether it is digits, that is what. So it's a combination of is alphabet and is digit. Now, if it is neither alphabet or digit, say if it's a special character or any other character, then it will return false. The second function is alpha. This function returns true if the character is an alphabet, or else it returns false. Is digit will return true if C is a integer value or its digits from 0 to 9, or else it returns false. Is lower will identify whether the character is in lowercase or in uppercase. If it is in lowercase, it returns true. If it is in uppercase, it returns false.
False.
Yes. Is print will identify whether the character C that we are passing as a parameter to this function is printable character or not. If it is printable, it will return true, or else it will return false. This function is punctuation. We'll find out whether the character C is a punctuation character or not. If it is a punctuation character, it will return true, or else it returns false. Similarly, is space will return true if it's a space, if C has space, or else it will return false. Is upper is a function which will identify whether the character is in uppercase. If it is an uppercase, it returns true, or else it returns false. On contrary to is upper, we have is lower, right? This to lower is a function which will actually convert C. If it is in upper, it will convert it into lowercase. But if C is already in lowercase, it will not make any changes to that. The last function is to upper, which will convert the character to uppercase. But if the character C, if the variable C contains case character, it will not make any changes. Now, this is a simple example program where we are trying to find out whether the input character that we give is alphanumeric or not. So you can see that I have included two header files. The first one being the stdio.h, standard input output. Input output. The second one is a C type. The C type is included so that we are using is alpha. Is alphanumeric is a function that we are using here in this program. So for that function to be recognized by my compiler, it needs a ctype.h. Okay. So my main program, I have a printf statement which will print enter the character, allowing the user to give an character as an input. This function here is alphanumeric. It's a conditional state, part of the conditional statement. It checks whether ch is alphanumeric or not. If it is so, if it is alphanumeric, then it will print that character followed by is an alphanumeric character. Else, if it is not alphanumeric character, then it will just print that character and followed by is not an alphanumeric character. So here we can see an output of this program. First, I've given h as an input. It clearly displays h is an alphanumeric character. Second run, I've given percentage as an input. So it says percentage is not an alphanumeric character. Okay, this is a small, this is another example where I've declared a character array. I've initialized it. 12 ABC 12 is the content of str. So this is a for loop where I am trying to check whether the string contains 0 or not. Yeah. So if I encounter actually I'm trying to check whether the given string is an alphabet or not. Here I'm trying to check whether it's a digit or not. So you can try out this example by yourself and check whether the output that we have got matches with the content given here. Okay, this is one program that you can actually try. The solution is of course given in your textbook, but you can try this program on your own. So it says write a program that reads a character from keyboard and then print it in reverse case. So if the character is given an uppercase, you need to check that and convert that into lowercase. Now, if the letter is in lowercase, then you have to convert that into uppercase using the functions that we have just seen. Okay, now these two functions that we saw in our previous slides were all unformatted input-output functions. Let's now try to focus on a formatted input function. As we all know, the formatted input function that C supports is scanf. The the general format is given in the slide. So scanf within brackets, the first part of your string is called the control string. Then we pass the set of parameters or the arguments. So the control string basically contains the percentage symbol. Now W represents the width, S and D represents the control, the formatted word. Some of the examples that I've given here I have three scanf statements. The first scanf statement, we have %d, ampersand num1, num2. So I'm giving the input as 30 and 31, 426 as inputs to num1 and num2. It takes it, no issues with that. Similarly, the second example that I've given where I've swapped these two numbers and given the input. So num1 will be 31, 426, num2 will be 50. But see the third example here, first one being %d, so it just accepts 123. Then I have a space here. Now here in the as part of the second input, now I have percentage star and D. A star indicates that I have to skip the input, which means that 456 will be skipped and it starts reading 789. 789 will be stored in B. So A stores 123, B stores 789. Okay. So are you all clear up till whatever we have done now?
Yes, sir.
Great. Okay. Now let's move on to scan type specifiers. So in the previous slide, we saw the control strings.
Sir,
Yes.
the previous screen, is there a mistake in the last line? Scanf %d star.
Yeah.
It's
In
a
the last
mistake.
line. So what is the
Yeah.
mistake?
Yes, sir. Yes, sir. The star. There is a star in the second percentage
Yes,
D.
yes. See, star. It's not a mistake.
Present
It's a
skip.
it's a yeah. It's a deliberate attempt of skipping the input, which means
Oh, okay.
that I don't want to accept 456. This statement will accept 123 for A, 289 for B. It will skip 456. I'll give you an example. Say I want to read the date of birth of a student in format DD, YY. But say for example, I have an hyphen between DD, and between and YY. Okay, so I want to skip that hyphen. So then I will use this percentage star there. So if I want to skip certain set of characters, I use percentage star. Is that fine?
Yes, sir.
Yeah. So these are the type specifiers. We have seen these specifiers in several of the programs that we have discussed in the class. C stands for character, accepting characters. D for decimal integers. Lowercase e, uppercase E, F, G, uppercase G, all stands for floating point values. When I say floating point values, the number can actually start with plus or minus sign. Obviously, it is optional. And then we have E that represents exponent, lowercase e or uppercase e, followed by decimal numbers. O is for octal integers. So if you want to accept octal integers, you need to use the type specifier O. S stands for string, array of characters. U stands for unsigned decimal integer. X, lowercase and uppercase, is for hexadecimal integers. Is to accept the hexadecimal integers. Now here's a small example program where I'm trying to accept two strings. I've declared character array str1, str2 of size 20, 30. I'm accepting the name and the website name using string 1 and string 2. Yeah, now this the next two slides will give you the difference between getS and scanf for a particular control string. The control string is percentage, and the next to percentage within the square braces we have caret symbol followed by /n. As you all know, /n stands for next line character. In C, whenever you enter a set of characters, maybe a string, and then press enter, that you can capture using /n. Now this function here, we have two programs here. One with one in black font, the other one with the blue font. The black font contains getS. I'm using getS function. You can see the parameter that I'm passing is name. Name is a character array. So I'll accept name from the user. %s is for accepting a string, is to print a string because we have printf statement here. Okay, the next code here, instead of using getS, I'm using scanf. Within double quotes, have a percentage symbol, and within square brackets, it is not next line character name. So what is the difference between these two programs? Now we need to understand the significance of not here. Okay, let me just get back. Okay, now getS will just accept the string and it displays the string, whereas scanf will accept the string. But what is the significance of caret here? Now caret indicates that within square brackets you have /n, which means that scanf will go on accepting any character until it encounters a /n, which means that until you press a key, press a enter key. Is that right? So until you press a enter key, whatever characters you give, your scanf goes on accepting it. Okay, this is a small. This is another example of input-output statements. I think it's pretty easy for us to understand. I have declared three different variables, one of type integer, the other one of type character, and the f as float. I'm accepting integer value in num and displaying it, floating point value in f and displaying it, similarly character and displaying it. See, this is the output of this program. So 10 is given as an integer, 2.5 as a float, a as a character. You should observe that the floating point value, even though you give it as 2.5, after the decimal point it displays 6 digits. That is the standard. Okay, this is another example program. Wherein I am using scanf to accept the address from the user. But here I have not just used percentages, rather within square brackets I have used a-z, that too in a lowercase a and z, which means that the address can be specified using lowercase letters from A to Z. Okay. Now the next statement here is printf. percentage hyphen 80s. So the address that is printed on the screen will occupy 80 spaces, but my string will get left justified. If I don't give hyphen, it will be right justified. If I give hyphen, it will get left justified. We can see here the input to this program that I have given is New Delhi. 1100002 is the pin code. I'm able to hear all sorts of noise. Can somebody, yeah, okay. So the output, if you just see the output of this program, a printf statement. Now, while accepting, scanf will accept only letters, lowercase letters. Now, there's a small mistake here. N and D is in uppercase. So if you want to accept even these two characters, then instead of just A to Z, you can also give uppercase A to Z. This entire string, that is New Delhi, will be accepted by this scanf statement. Okay. Yeah. Now here we can
So
see.
then how will the pin code be accepted?
Hello. Yeah.
Hello. So how will
Yes.
the pin code be accepted?
No, that is what here you can see. Pin code, if you want this program to be accepting it, so you have to give 0-9 here after A to Z.
Okay, okay.
You also
So in the
include
scanf,
yeah.
so in the scanf statement only, we have to give that pin code statement.
Which code?
So means as said by our friend, he
Yeah.
said that how the pin code will be accepted. So for that only we have to give that command
Yes,
in
yes,
scanf
yes.
statement only.
Yes. See, these are called as meta characters. Okay.
So
Now,
we can store any kind of characters, sir, like
yes, any
integer, lower
uppercase,
character.
uppercase, lowercase. See, when you say, see, this is A to Z, right? So, say for example, you want to accept accept floating point values. So, if it is floating point values, then E will be obviously accepted by uh, uh, this scanf already, because E is included in A to Z. But then you have to include even plus, minus, so that it may be part of your floating point values, right? So if you want to make it a generic format for accepting anything, include all those patterns within the square braces. It accepts. Let me show you the next program where I have accepted even the pin code. See this, I've just replaced it. Instead of A to Z, I've just said caret and /n. Now this caret, as we have already discussed, this is like a not operator. It will accept the address, the content of this address, until you press the enter key. So apart from the enter key, whatever key that you press will be just accepted by this scanf statement. So here you can see that I've given input as New Delhi 1100002. It has accepted the entire address, and then here in printf, I'm printing the address. Of course, this time I've also used hyphen and 80s. So 80 is the number of spaces that it will occupy. S, as I said, is left justified. So it will accept New Delhi 1100002.
So can you again explain the print statement?
Yeah, printf statement. See, assume that you have only percentage yes. You don't have minus 80. So if that is the case, if you just have percentage s, it will print New Delhi, no doubt in that. Okay. Now, if you have hyphen 80 here, 80, I am representing the width of the string. It is the maximum width of the string that I can allocate for printing the string. Hyphen is left justified. If I remove this hyphen, say for example, if I remove this hyphen, the size of my string is 80. So New Delhi with the pin code will be right justified. So what is the size of my string? Say for example, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 80 minus 16, how much is it? 64, 62. So it'll have 62 spaces followed by New Delhi followed by 110002.
Okay.
If I don't give hyphen, that is the idea. Okay. So scanf, we saw the, I think we saw the, what is it? Yeah, we saw the format. Let's see the conversion specifiers for scanf. D stands for integer. We all know this. I also stands for integer, but then I can also represent or can also accept octal hexadecimal integer values. O stands for octal integers. U is for unsigned decimal integer. X, lowercase x, uppercase x is for hexadecimal integer. H or L. H or L stands for short or long integers. Now, whatever we saw was with respect to integer values. This slide gives us the conversion specifiers for floating point numbers and characters with the strings. Floating point numbers, to specify, to accept floating point numbers, you have E, lowercase e, uppercase E, F, G, uppercase G. Whereas for long and long double, we use L and lowercase l and uppercase L. C stands for character, S stands for string. One thing you need to always remember, if you are trying to accept a string, the last character at the end of the string will always be a null character which your compiler automatically adds. Okay, now these are some of the examples. Okay, just a minute. Example programs. Here you can clearly observe that I have declared several variables A, B, C, D, E, F, G, all of integer type. But whereas while accepting it, you can see that I've used a certain set of controls, commonly used format codes. D, I, O, U, X. Now D is to specify the decimal integers, I for integers, O for octal, as we have just discussed, U for unsigned decimal integers, X for hexadecimal integers. So here we can see the output of this program. I have entered values like -70, -70, 70, OX 70. OX 70 is for hexadecimal. Now hexadecimal should always start with 0x. Previous to that, if you see the third value is again octal value.
Octal.
It's now octal because we are starting with 0 again,
Hmm.
and followed by 3 more 70s. So you can see the display of these values. It's -70, no change, -70, but here you can see it is 56. Why is it 56? Because it's a octal value. Remember that this is octal value. Similarly, 112 is for hexadecimal,
Hexadecimal.
octal, 70, and then again hexadecimal.
Hexadecimal.
Yeah. This is an example program to demonstrate floating point numbers. Here you can see LE, LF, LG. So E, F, G specifies floating point numbers. So here you can see that I've given 3 different values. 1.27987. Similarly, the other 2 values with exponential values. These are the values that are printed. Okay. Now, when I try to print values, the formats that I've given, this the scanf format codes that I've given is all F. So it's all floating point notations. So there will be no exponentiation that will be displayed here, as we have given as the part of the input here. So after point, you have 6 decimal digits. You need to observe that. Yeah, this is an example program to demonstrate characters and strings. Scanf %C %S. So %C, you need to observe here. I've given ampersand x. X is a character variable. Y is a character array, which can actually hold 9 characters in it. So %C for character, %S for string. So this is the input that I give. Enter the string Sunday, right? So the first character will obviously be S. So S is pushed into X. So the character is S, and the string, the remaining part of the string, that is UNDAY, will be part of my string Y here. Observe that there is no space between S and the remaining part of the Sunday, but still the remaining set of characters are pushed into the string Y. Yeah, this is another very good example. Here in the scanf statement, the control code or the format code, I've not specified any format code, but then within square brackets, I have presented the vowels here, A, E, I, O, U, which means that when I am accepting the string, I should accept only vowels from that string. Z is a character array. Here you can see accept string O E E O E A H E A H. So here it's a clear indication that I should accept only vowels. So O is a vowel, E is a vowel, A is a vowel, H is not a vowel, it's a consonant. So only the vowels in the string are accepted. What if I don't want the vowels and I want to accept only the consonants? What changes will I make here in the scanf statements? Can anyone answer me? You need to just put a caret. When you put a caret, it's the negation of the characters, which means that you accept all other characters except what is present within the square brackets. Right? This is an example where I have a caret here. I don't want to accept any of the vowels. So here you can see I am accepting string. Once I encounter I, the scanf statement stops reading the string and it will just display str. Okay. This is an example where I am using a field width specifier. Up till now, we have seen percentage and then followed by the um, format codes. Here, I'm introducing 2 here, 2D, percentage 2D. A percentage 2D, it will read only the first 2 digits of the input that you give. You can see here uh, the uh, the input that I have given is 1, 2, 3, 4, 5, 6. Out of which 1, 2, the first 2 digits is accepted by X, remaining 4 digits is accepted by Y. So width can also be specified. We have discussed star already in our previous slide. So this is the example that I was just discussing. MM-DD-YYYY. So I have to give the input in this format. Obviously it's month represented by 2 digits. And after that I give one hyphen, which is not accepted, followed by 2 Ds, 2 digits representing day. That follows another hyphen, which is again removed by this star here, followed by 4 digits. It accepts. Now see here, if you see the output 11-18-2003. So 11 is accepted to month, 18 to day, and 2003 for years.